Continuing with section 1.5, we are now going to look at non-homogeneous systems. So solutions of non-homogeneous systems. So there is a theorem. It says, suppose the equation Ax is equal to b is consistent for some b. So what does it mean? Consistent means it has a solution, has at least one solution for some b, some vector b. And let vector p be a solution. So let us say that there exists at least one solution to the equation, and we are going to call it p, the vector p. Then the solution set of Ax is equal to b is the set of all vectors of the form w equal to p plus t times v sub h vector. So what is this v sub h vector? It is the solution of any solution of the homogeneous equation. I believe we would like to be the non-zero solution, because zero solution will just give us the p vector only. So if we have a non-zero solution of the homogeneous equation, then the solution set of Ax is equal to b will be the vectors of this form. P vector, p a certain known vector, plus t times the vh vector, which is the solution of the homogeneous system. So let us look at this example. This should have been example number 4. So it says find the solution of this system, and then B part is now solve the following system, write the equation in parametric vector form. So now we have to solve the system again with the number. So what I am going to do is I am going to actually do both together instead of wasting the time. Just to save time, I will be doing them together. So you will understand what I am saying in a minute. So we are looking at example 4. So the matrix that we are getting is 1, 2, -3, 2, 1, -3, -1, 1, 0. And then for the A part, we have to do the 0, 0, 0 here. Now just to save the time, because remember in the other one is where we will have the numbers instead of zeros here, we will have the number 5, 13 and -8, which is the right side of the equations. So I'm going to do this here. So this is my for the homogeneous case, and this for the non-homogeneous case. So I'm going to do them in the one go, because the same steps you will have to do for the non-homogeneous case separately. We don't want to do that. So what is the first thing so I have now 2 vertical lines here, one separating the zeros and the right side of the homogeneous system and the right side of the non-homogeneous system. Okay, we have the one here which we want, right? We have the one here, and we want to make this 0 and this 0. So multiply the first row by multiply the first row by -1 and add in the third row. Maybe you want to do the second row first, so multiply this first row by -2 and add in the second row, and at the same time I can multiply the first row by -1 and I'm going to add it to the third row, R3. So first row is not changing. second row will change because we have to make this a 0. So we multiply the first row by -2. So the second entry, when multiplied by -2, becomes -4. And then we have to add it in the second row, which means +1. So I end up getting -3. And now when I multiply this quantity by -2, I end up getting +6. And then I am adding it to -3. So it will give me 3. 0 just stays as 0. So now we apply it on the last column. So multiply the first row by -2, which makes it -10, and add in the second row, which means I'm left with 3. Now for the last row, third row, we will just add the first row in the third row. So we get 0, 3, -3, 0, -3. Okay, so the next pivot is over here. So we can divide it by 3 and then work, but if you notice at this moment I just need to add the second row into the third row. So R2 plus R3 give me the second new third row. So 1, 2, -3, 0, 5. So first row did not change. Second row, well, did not change, right? But the third row, when we added the second row and the third row, notice that this became all zeros. Okay, which means next is the pivot is this one, so we make it 1. So we are going to do -1/3 R2. So the first row remains the same. So second row, what we did with the second row, we just divided by -3. So I end up getting 1, -1, 0, and then 1, -1. And the third row is just zeros. Okay, what is the next step? Well, we have to make this quantity a 0. So I will multiply the second row by 2, -2, and add it into the first row. So this gives me 1, 0. So I am multiplying by -2, so I am getting -2 in there. So I get -1, 0. Okay, so 7. And 0, 1, -1, 0, -1, 0, 0, 0, 0, 0. So this is the echelon form, reduced echelon form. Now again, x3 is a free variable. So we can say let x3 equals a t or s. Then we have x1 minus x3 is equal to 7. So this is for the first one, actually for the A part, what is the solution? X1, so I think I shouldn't write this over here. For part A, x1 minus x3 is equal to 0. x2 minus x3 is equal to -1. No, it will be 0 again because that is okay. So the first one gives me x1 is equal to x3. or equal to t, and x2 will be equal to x3 also, which means equal to t, which means the x vector is or if I try to sketch it, it is the vector which is 1 unit on this axis, 1 unit on this axis. So you can imagine there is a vector which starting here, it's coming out of the paper, so we have to try to put it somewhere. So I'm just going to make it like this. This is the vector going through the origin. So that's kind of the vector that we are looking at. See, it's not that easy to something like that. So this is our solution vector. Now what about for part B? So for part B, we will have x1 minus x3 equals 7 and x2 minus x3 equals -1. So from first one, we have x1 is equal to 7 plus x3 and x2 is equal to -1 plus x3. So that the x bar is going to be x1, x2, x3, which is 7 plus x3 or t, and then -1 plus t, and then I have t. Now I can write it as a sum of these two vectors, 7, -1, 0, plus t, 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 which can then be written as 7, -1, 0, plus t times 1, 1, 1. So now, what does that mean? So it means, so where is the vector 7, -1, 0? Well, this means the third component is 0, so it means it is in the plane of the first and the second component. This is the first component, this is second component, and this is the third component of the vector. So it will be in the horizontal plane. So the vector, let's say it's because it says 7, so 7 on the x-axis, -1 on the y-axis, so -1 back on the back side. So somewhere here we have our vector, this one, u, and the v vector is what we have. So you see now again we get a plane. So this is our u, and this is the v vector which we got from the homogeneous solution as well. So we are getting a plane tilted plane which is passing through the origin. So this is how we solve the. So note here now, So what happened is that we got a non-trivial solution here. So non-trivial solution. What was it? It was 1, 1, 1. So there were a bunch of them. Let's just pick 1, 1, 1, right? So the vector equation, and for this case we had a solution 7 minus 1, 0. So this we call particular solution, we denote it by P, and this way we call the solution from the homogeneous equation BH, so that the final solution of this system solution, it can be written as, from this example that we did, we saw we wrote it as P plus TVH. So this is how we can write the general solution of a homogeneous system of linear equations. Okay, in the next section we will be looking at linear independence. So in the next video we'll see that.